Next gen battery offers increased energy density, quick recharging, which is always good, and longer lifespans for diverse applications. Medical devices, robotic arms, and military drones stand to benefit from this breakthrough. Production hurdles, though, would include sourcing rare earth materials like lithium. We've had lots of conversation about that. Of course, amid tightening global supply chains, the battery's adaptability is going to make it a game changer for industries prioritizing portability and efficiency. Experts do predict, though, that it could reduce operational costs, which is huge, and expand the capabilities of power-reliant technologies.
So Ultralife has done something really cool here. And I think the coolest selling point is that they're lighter. The lithium iron phosphate with all sorts of use cases because it's lightweight for lightweight motorized things, for data backup apps. It's 3 times lighter than the SLA alternatives. They're able to be connected in series so that you can get more power as you need, rechargeable with a variety of sources, including renewable energy. And it is supposedly, they claim, can be embedded in a fit and forget way, and because they're not going to become gaseous during use, working over a wide temperature range, so lower cost of total ownership. A lot of really cool selling points. I mean, they're saying it's 2,500 fully cycled power cycles here compared to the typical 300 to 500 that happen with SLA. So solid design, sounds like solid testing. If it all is true, this means the biggest challenge is going to be making enough to meet the demand, because this is going to have a demand for a lot of cases. So can you scale this, and how do you do so?
Yeah. And connected straight into can you scale this is going to be on the back of another breakthrough battery that solves everything. And this is going on all the time because battery is still in its relative infancy, isn't it, in terms of its design maturity, its delivery maturity. The problem here is everything's great, except how you can actually get the materials to build it, to produce it, to manufacture. Because what's a cutting edge power source without a good old fashioned supply chain crisis? I mean, that's what we live with every day. So it's supply chain.
It's true that supplies are required to make things, and figuring out how to take those supplies and make things at scale and make sure that the quality stays the promised quality. I think all of these things have to happen. They're all related, and that's what we're going to have to look at.
Yeah. So, I mean, every new battery is promising more power. It's faster charging. It's longer life. It's fantastic. But there's just one tiny little issue here. Where are we getting all of this lithium from? Probably China. Anyway, there we go. You can't revolutionize robotics, medical devices, defense issues if your production line is stuck waiting for raw materials that are controlled by half a dozen suppliers globally. So at this rate, we're going to be powering a next-gen drone with a AA battery from the corner store, in my opinion.
Now, that would actually be pretty cool.
It would be. You need a lot of them.
And just one. If you could get it down to just one.
Yeah. Just one. Okay.
So it all goes back to the supply chain. Can we actually have enough supplies that are the critical supplies to make this work? And
AI.
Solution goes back to, if only we've talked about this before, huh? Yeah, never talked about AI on this show before.
No, especially in the supply chain. See you next one.